Today the topic for discussion is problems on the forward difference operator, backward difference operator, and the shift operator E. And the first problem is construct a forward difference table for the following values. So what are the values given? X values of these are the values of X in first row and the values of Y in the second row. So we have to construct a forward difference table. Okay, so this is the forward difference table. That is, write the values of X in first column, write the values of Y or fx in the second column, and the first difference, second difference, third difference, fourth difference, and fifth difference. So here the values are given, values are 6, that is the values of X or Y are 6 values, and that's why we have the table at the delta raised to 5. Okay, if the values are 6, then the table terminated at delta raised to 5. So if the values are suppose 5, given values of X or Y are 5, then the table, this forward difference table terminated at delta raised to 4. That is at the fourth difference. Okay, so if the values are suppose given 10, then the last table is what? Last column of the table is what? Delta raised to 9fx if the 10 values of X or Y are given. So here 6 values are given, and so the last column is what? Delta raised to 5fx. If the values are 5, then the last column is delta raised to 4fx. Okay, so because after these values are given, values are 6 in number. So in the first column, this delta in the first difference column is what is the delta fx, contains 5 values. Then the delta raised to delta square contains this column contains 4 values. Then this column contains 3 values, 2 values, and last column contains 1 value. Okay, 1 entry. So 6 values are given, and therefore we have the last column delta raised to 5 fx or y. Fx or y, the notation for fx is also y. So write delta raised to 5y, delta raised to 4y, or delta raised to 4fx, delta raised to 5fx. Okay, so and what are the next difference? Delta raised to 6fx, that is the next differences are all 0. So 6 values are given, then the delta raised to 6fx, delta raised to 7fx are all equal to 0. That is, if the 6 values of X or Y are given, then the differences from 6 order and further differences are all equal to 0. So what is the increase in the this first difference column? That is delta fx or delta y. So this is the forward difference table. If we have to construct the backward difference table, then instead of this delta, write only del. And the procedure of obtaining the forward difference table and backward difference table both are same. And what is the method? Then what is the increase in the first column of this first order difference? That is delta fx. So this entry 10 minus 6, that is 4. So write 4 in the first place. Write 4 in the middle of 6 and 10. Then 13 minus 10 is 3. Then 17 minus 13 is 4. Then 23 minus 17 is 6. And then 31 minus 23 is 8. Because we know the definition of forward difference table. What is the forward difference table definition of? What is the forward difference operator? That delta fx is what? Is f of x plus h. What is delta fx? Is f of x plus h minus fx. That is the value at the next point minus value at the same point. So we have these entries. Then the next column is delta square fx. So so again the same procedure, 3 minus 4, that is minus 1. So write minus 1 in the middle of this 4 and 3. And then 4 minus 3 is 1. Then 6 minus 4 is 2. 8 minus 6 is 2. Then delta cube fx. Then this minus this number. So minus minus become plus 1, that is 2. Then 2 minus 1 is 1. 2 minus 2 is 0. And the next column delta raised to 4fx is what? 1 minus 2 is minus 1. 0 minus 1 is minus 1. And then last column delta raised to 5fx is what? This minus this number is 0. both are same, their subtraction is 0. So this is the forward difference table. So if the question is construct a backward difference table instead of this forward, if there is the word backward and given the same, suppose given the same table, and we have to construct the backward difference table. So write the backward difference table is, so write the values of x, write the values of y, and just write here del fx, here del square fx, del cube fx, del raised to 4 fx, del raised to 5 fx. Instead of delta, in we write del square, del square. Okay, if we have to construct the backward difference table, and all these entries are same. That is the procedure of the obtaining forward backward difference table is same. Only replace this delta by del. So next example is of backward difference table. So what is the next example? Construct the backward difference table. For this writing is this sentence, the previous problem. See the previous problem, we have the forward difference definition is delta fx is what? F of x plus h minus fx. Delta square is delta of delta fx, etc. And h is 5. So this sentence, these two sentences are not required in these examples. But uh, what is this sentence? This is the definition of delta fx, delta square fx. And what is h? H is the common difference, 0, 5, 10, 15. So what is the h? The common difference is what? Is 5 in the values of x. So this h is, so, but there is no need to write these two sentences because the question is what? Only construct a forward difference table. So don't write these two sentences, only directly write the forward difference table. The next problem is construct the backward difference table. The values of x and y or fx are given. Again here h is what? 10, 20, 30, 40. The values of x are equidistant and the distance is 10. So h is 10. But no need to write these two statements in this answer of problem, because the question is construct a backward difference table. So write directly this backward difference table. So what is, we know the definition of a del fx is fx minus value at the previous point, value at the point minus value at the previous point. So write the values of x. So here the values are given what? In 5 number. Values are in 5 in number. So we have the last column del raised to 4 fx. If the values of x or y are 6 in number, then the last column is what? Is del raised to 5 fx. So here the values are 5, and so del raised to 4 fx is the last column. And what are the next differences? That is del raised to 5, del raised to 6, all are equal to 0 because 5 values are given, and so we have the last column del raised to 4 fx. So write the values of y or fx in the second column. And what is the third column? Is del fx. The third column, next column is del square fx, del cube fx, or del raised to 4 fx, or write fx or y. Okay. And what are the entries in this column? Del fx, then again 65 minus 45, that is 20, 80 minus 65, that is 15, 92 minus 80, that is 12, 100 minus 92 is 8. That is the procedure of preparing backward difference table and forward difference table. Both is same. Just write in a forward difference table delta, and in the backward difference table del. Okay, so this is the backward difference table. The procedure of preparing backward difference table and forward difference table is same. Then this minus this, 15 minus 20 is minus 5, 12 minus 15 is minus 5, 8 minus 12 is minus 3. Okay, and then again the next column is what? This minus 3 minus 5, minus minus become plus 5, that is 2. Then this number minus this number is the next entry. Then this minus this, minus 1 minus 2 becomes minus 3. So this is the backward difference table. Next example is prepare the forward difference table. We are given the function is what? X cube plus 5x minus 7, and the value of x are what? Minus 1, 0, 1, 2, 3, 4, 5. The values of x are equidistant, and the distance is what? Is 1. the common h value of h for this x is what? H is 1. The common difference is 1. And what is the question? Prepare the forward difference table and obtain F6 and F7. So first we prepare the forward difference table. So write the values of x. So values of x are what? Are 1, 2, 3, 4, 5, 6, 7. 7 in number. Similarly, the values of y or fx are 7 in number. And therefore, the last column is what? Is delta is to 6 fx. But we terminated this table at delta cube, because if all the values are similar in any column, here we observe this column, all the values are same, 6, 6, 6, and therefore no need to construct further columns, because what is the next column? Delta raised to 4fx. What is the value of delta raised to 4x? What are the entries in the delta raised to 4fx? All entries are 0. So 6 minus 6, 0, 6 minus 6, 0, 6 minus 0. That is, all the entries in the further columns are 0, and so no need to write the further columns. If the values at any stage, at any column are same, all the values, all the entries are same, then no need to construct a further table or further columns. Okay, so otherwise here the values are what? 7 in numbers. Then when the table terminated, or when the last column of, what is the last column of the table? The last column of the table is delta raised to 6fx, but all the values are similar in this column, and so no need to write the further columns. So what is the forward difference table? So write the first column is what? The values of x that are given, and what are the values of y or fx? So find the values of fx or y at x is equal to -1. That is, substitute x is equal to -1. So -1 cube is -1. 5 into -1 is -1, -7. So this becomes -30. Then value of 0 is what? At 0 is what? Value of fx at 0 is what? Substitute x is equal to 0. So this is 0, this is 0, -7 is the value at 0. Similarly, substitute 1, substitute 2, 3, 4, 5, and these are the values of fx or y. So the next column is what? Delta fx. This minus this value minus this value. So write this value minus this value in the middle of these two. So 35 minus 11, and 77 minus 35, 143 minus 77, that is 66. Then next column is what? Delta square fx. This minus this 0, this minus this 6, 24 minus 12. Well, okay, all these entries. Then 6 minus 0 is 6, 12 minus 6 is 6, 18 minus 12 is 6, 24 minus 18 is 6. Okay, that is, all the entries in this column are similar, same, and so stop here. No need to find a further table. Then we have to find the value of F6 and F7. We have to find the values of F6 and F7. Some problem in sharing. Some problem in sharing the screen. Okay, now the screen is sharing. So we have to find the value of F6. So what is e raised to 7 of f of -1? That is, shift the point f of -1 to 7 places. So if we shift the point -1 to 7 places, then what we have? 1, 2, 3, 4, 5, 6. That is, we have to shift the -1 to 7 places. So -1, 0, 1, 2, 3, 4, 5. So see the f of e raised to, if we shift the point -1 to 7 places, then what is the value? Suppose this -1 shifted to 7 places further. So first place is 1, 0, second, third, then this is 4th place, 5th place, 6th place, and 7th place is what? 6. So e raised to 7 f of -1. see this, e raised to 7 f of minus 1 is what? Is f of 6. E raised to 7 f of minus 1 is f of 6. So we have to find the value of f of 6. So what is f of 6? E raised to 7 f of minus 1. So choose this number f of minus 1. This is the first number. So write f of 6 as e raised to what of the first number. So e raised to 7 of f of minus 1. So this number we have to find is 7. And this number is what? F of minus 1. How we can take this f of minus 1? Because the first value is minus 1. So similarly, f of 7 is what? E raised to 6 of e raised to 8. Here is wrong. This 6 is wrong answer. Here is 8. E raised to 8 f of minus 1. That is, if we shift minus 1 to 8 point, then we have the value f of 7. Okay. So because we know that f of e value of e of fx, definition of e of fx. What is e of fx? E of fx is what? Is f of x plus h. E square f of x is what? Is f of x plus 2h. Similarly, what is e raised to 7 f of x? Is f of x plus 7h. h is 1. So f of x plus 7 minus 1 plus 7 is 6. Okay. So and then e value of e is what? E is 1 plus delta. So 1 plus delta raised to 7 f of minus 1. Then obtain the expansion of 1 plus delta raised to 7 by using binomial theorem. We have total 8 terms. But here only the first 4 terms are given because the further differences are 0. So what is the power of x plus y raised to 7? Expansion of x plus y raised to 7. The expansion of x plus y raised to 7 is what? We have the total 8 terms. So here the first term is what? The first term is what? X raised to n. X raised to n. nc 7c 0. 7c0. The coefficient of 1 is what? 7c0. 1 raised to 7 is 7. Then plus 7c1. The next term. So what are the coefficients? 7c0, 7c1, 7c2, 7c3, 7c4, 7c5, 7c6 and 7c7. The last coefficient of the 8 number terms. Okay. So the expansion of this 1 plus delta raised to 7 contains total 8 terms, but the only 4 terms are taken in this bracket because the further differences, because we observe in table delta raised to 4, delta raised to 5 all are 0. So this is the first term. Then second term is what? 7c1, 1 raised to 6 delta into delta. Then 7c2, the first term 1 raised to 5, but 1 raised to 5 is 1 delta square. Okay. This is the by using binomial theorem. 7c3, the fourth power of this one and third power of this delta. Okay. The further terms are not given because all the further terms are what? The next term is 7c4 delta raised to 4. Next term is 7c5 delta raised to 5 and all the remaining terms. But the differences are, the further differences are 0 because we observe in this table the delta up to delta cube, the terms are non-zero. The remaining terms are 0. Delta raised to 4 fx is what? 6 minus 6, 0, 6. All increase in the delta raised to 4, delta raised to 5 are 0. That's why here the further terms are not given. Actually 1 plus delta raised to 7 contains 8 terms. But here only the 5 terms, 4 terms are given. Okay, what are the next term? 7c4 delta raised to 4. But all these terms are higher, differences are 0. That's why the further terms are not given. Actually 1 plus delta raised to 7 contains 8 terms. Okay, f of minus 1 is it. Then the next term 1 into f of minus 1 is f of minus 1 plus 7c1 is 7. By calculator we can find this combination, value of this combination 7c1 is 7 and del of f of minus 1, not del, delta of f of minus 1. Then 7c2 value is 21. Find this value by using calculator. Delta square f of minus 1. Then 7c3 value is 35 and delta cube f of minus 1. And then f of minus 1, value of f of minus 1 from table is minus 13. Then delta f of minus 1 is 6. This is also from table. Observe the table. Delta of f of minus 1 is 6. delta square f of minus 1 is 0 and delta cube f of minus 1 is 6. So these values are from table. This is the forward difference table, so these values are important, that minus 13, 6, 0 and 6. If the table is backward difference table, then these values are important. The bottom values are important. So the value of delta f of minus 1 is 6. Delta square f of minus 1 is 0 here. Delta square f of minus 1 is 0 and delta cube f of minus 1 is 6. So these values are from table, and the addition and the multiplication and subtraction of these numbers is 239. So f of 6 here is again p. This is not p. Here write 6. So f of 6 is what? 239. Okay. Similarly, f of 7 is what? E raised to 8 f of minus 1. And what is e? 1 plus delta raised to 8. Again, the expansion of 1 plus delta raised to 8 contains 9 terms, but here only the 4 terms are given because other differences are 0. Then multiply by f of minus 1. And again, delta f of minus 1, delta square f of minus 1, delta cube f of minus 1 are substituted from the previous table. And the value of this 8c2, 8c1, 8c1 is 8, 8c2 is this 28, 8c3 is 56, and this is calculated by using calculator. And then values are, the value of f of 7 is what? 371. Okay, the calculation of this. So these are some problems on the forward difference operator, backward difference operator, and the shift operator. And the remaining problems we will see in the next lecture. Also, the same type problems we will see in the next lecture. The problems on the forward difference, backward difference, and shift operator.